Now, coming to tonight's session, please allow me to welcome Vineet Sethi, the moderator of this session. Vineet is an inquisitive and data-savvy professional with the heart of an entrepreneur. He's passionate about building products that can empathize with the user's needs and evolve themselves through repeated experimentation. Most recently, Vineet has been driving the adoption and engagement of SaaS-based B2B products at Boston Consulting Firm. He's a core member of the product team and collaborates with different stakeholders to ensure that the products are getting developed with the right strategy and customer empathy. Vineet also likes to talk to different people and learn from their experiences. Great to have you here with us, Vineet. Handing the session over to you.
Thank you so much, Shama, and thanks for the introduction. And welcome everyone, first of all, to this session. I'm sure it is going to be an exciting session today, and with some great learnings from our esteemed speaker. So with that, I would like to welcome Saurav as well. So welcome, Saurav. Okay, so regarding today's topic, I'm sure most of you have heard about NLP, natural language processing, which is like a major term in the data science world and the artificial intelligence world today. But for some of you, for whom this term might be like a very naive term for you, let me tell you that NLP is a subset of artificial intelligence, which helps process large amount of human language data. It's an end-to-end process between systems and humans. And the most common example of NLP or the application of NLP is the chatbots that we see today. But with the growing advancement of data, with the growing advancement of these different technologies and the algorithms to deal with this large amount of data, our speaker today believes that though the algorithms are becoming smarter and smarter day by day, but the data is becoming dumber. And our speaker believes that to handle that dumbness of the data, knowledge graphs are one of the way to tackle that. We would surely love to know how that is done and what are the practical use cases around knowledge graphs in the world of NLP. So, and what makes our speaker give that talk today? So let me tell you a bit about our speaker today. Saurav Chakravarti is a hardcore data scientist and currently leads the artificial intelligence initiatives for Freshworks. I'm sure Freshworks, everyone has heard of it. It has had a recent very massive IPO at NASDAQ in USA. But that's not it. Saurav has led a massive data science initiative projects in his previous organizations also, which is Brilio, where he developed the core IP and build these minimum viable products around computer visions, NLP, and also help them develop their Brilio Academy, which focuses on learning initiatives around data science. That's not it. Our esteemed speaker today has also been the visiting faculty at some of the prestigious colleges, such as IIM Calcutta and Narsi Munji, where he has led topics and taught topics on artificial intelligence, analytics, visualizations, and whatnot. And to put icing on the cake, our speaker for today is an IIT alumnus, IIT Kharagpur to be exact, and IIM Calcutta alumnus also. With that said, our speaker for today, Saurav, loves to write about topics which helps the users or about building their digital presence and how do we communicate in the real world to different users. And also, he's an active member on LinkedIn with more than 4,200 followers currently. And he's an active writer on Medium also. So do check out him on LinkedIn and follow him there. So with that said, with that said, I welcome you, Saurav, and thank you so much for taking out time to be our speaker today. And over to you to share your experiences.
Thank you, Vineet. It was a very interesting introduction. I didn't realize that you'll dig up my background in that detail.
Okay.
So you want me to share the screen and get started?
Sure, Saurav, you can do that. And also, Saurav, I can see two guitars also in the background. So do you have a personal hobby of playing guitars as well?
No, it's my kid's guitar. He ran out of space in his room, so his older guitars he has moved to my place.
Got it. Got it.
So for me, it's a background showpiece.
Nice. Nice. Cool then. Over to you, Saurav.
Thank you. I see that we have 49 people, and welcome to this forum. It's a great opportunity to talk to you. Thanks, Vineet and Shama, for inviting me here. I hope it will be interesting to understand what we do in Freshworks. This is related to the work we do in Freshworks, not exactly the same work, but some of the ideas, some of the approaches that we are using here to solve our own problems. I hope that this will make sense to you. But there's one concern here, Vineet. You started with an explanation of NLP. Now this talk here in some way assumes that there's a little background of data and analytics involved and people already understand NLP. So
Yeah.
is that understanding wrong? I mean, should I start with very basics or people are already aware of what NLP and such techniques are?
Audience, you can go ahead and put your opinion and views and answer the question that Saurav asked in the chat window. So we'll know your background better as well.
Yeah.
So we'll give them a few seconds to put down their ideas.
Sure.
Okay. Okay, we have a mixed audience here, with few of them with the background of NLP and few of them with no background. But I think if you could just brush up on the basics quickly, then that'll help Saurav, if that's okay with you, or you can start with your
all right. No. We'll see how it goes. I understand broadly where we are, so I think it's a mix of folks. Okay, so what I'll then do is I'll give you a little background about what product I work on. I think Vinesh spoke about Freshworks as a company. Inside Freshworks, there are a bunch of products. One of the products that I am personally involved in is called Freshservice. Freshservice is a SaaS-based ITSM, ITOM, ESM tool. And what it means is, if you, for example, inside your organization have used any tool to request for any kinds of services, like from requesting for a new laptop or requesting a backup of your hard drive or requesting for some business cards or trying to figure out the leave policies of your organization. So anytime you do something like that, you might use a tool like Freshservice. This is a SaaS-based tool, which means the way you buy this tool is go out to freshservice.com, select subscribe or buy the tool, pay via your credit card or something, and then you start using it. It's like if you guys are using Zoom, for example, it's like using Zoom. So there is no customization, there is no hand-holding, there is no onboarding, there is no implementation, everything is SaaS. So that's broadly to give you the context of how Freshservice works. We have thousands of customers. Each of those of our customers would have potentially thousands of agents and employees who will be using this tool. If you go over to our website, you'll see some of the brands that we use. What we try to do is to make employee experience great. So to give a great employee experience, we want to get users, get help to the users in the same place where they spend their everyday life, which, as you know, in these days is probably Microsoft Teams or on Slack. So we don't want our users, that is the employees of the customers that we serve, to go to a separate portal, type in their queries or create a ticket and do something. We want them to do all of these things over Teams and Slack. And we also want them to have a great experience. And by that great experience means that the conversation on Teams and Slack should be as close to a real conversation as possible, which means a conversational agent should be there. And only if that agent, that virtual agent isn't able to solve their problems, only then a real agent should get involved. And this is primarily to ensure that the employees get timely service and the agents are not overwhelmed by the whole process. So the field that I'm going to talk about relates to how a virtual agent works on Teams and Slack, and how this whole ecosystem needs to be supported. And therein comes in the concepts of NLP, because when you type something on Teams or Slack, you type it in natural language, and our virtual agent needs to have the ability to understand natural language. NLP is natural language processing. There are other terms which are used, like NLU, which is natural language understanding, and NLG, which is natural language generation. So when employees type in something on Slack, let me give you an example of that. They type in things like, hey, I'm running into some VPN issues, can you please help? We should be able to understand this whole context and provide the troubleshooting guide for VPN. And we do a good job only when we find the right article in the right context and in the right manner for our users. So this is like troubleshooting, but you could also imagine things like service requests. So if I type, I need to install VPN on my laptop, then you can imagine that this changes to a form which allows you to fill in your details and put in a request saying that somebody please come and install VPN and give me access to VPN services. So this is what our job is. So our job is to get this natural language and map it to a certain backend knowledge base, or what we call service items, and fetch those information back to the user. So the motivation behind this problem started whatever I'm going to describe. We have had this system for a while now. We have virtual agent live for quite some time in our systems. But we, as you know, with many of these systems, these need debugging and review periodically. And while understanding how our virtual agent performs, we realized that one of our users in one of our customers had requested for JetBrains IDE. Now, for those of who who are aware of this company, JetBrains manufactures IDE, and some of those IDEs are IntelliJ, PyCharm, etc. So JetBrains is not the name of an IDE. IDE is integrated development environment. So JetBrains is not a tool. JetBrains is a company which makes tools. But IntelliJ is one of their oldest and one of their most mature products. And when people say JetBrains, they typically mean JetBrains IDE or IDE by JetBrains, they typically mean IntelliJ. And our virtual agent failed to do this, right? And when we dug a little deeper, we realized that there was a service item for IntelliJ, but JetBrains and IntelliJ were not connected. So when the way the system here works is, once we understand this question, we trigger a query to our knowledge base or our catalog, and we try and retrieve. It's like Google search. We try and retrieve what is the right information. So in this case, it is easy because you see the word VPN here and you see the word VPN here. There is some match. The only thing that we have to now figure out is that we need to figure out troubleshooting guide and not installation guide, right? That's because somehow we understand this user already has VPN, and so they're not looking at a way to install it. They're looking at a way to troubleshoot it. So this is the the problem statement that that had us there, that how do we encode the information that JetBrains IDE is in some way referring to IntelliJ IDE as the answer. And this is not a trivial problem. This is a very complicated problem, because unless you know that JetBrains is the company which manufactures IntelliJ, you can't do that. This problem has been solved. It's not that this is a non-solved problem. So this is, again, I didn't realize that this is a mixed crowd, but for those of who you are familiar with the concept, there was a very nice paper where we call of in 2013, I think, which introduced the idea of word-to-vec. And what this means is words are converted into a vector of it mathematically. They're following well. So what you can then do is, if you have a word represented as a vector, then you can do a vector level comparison, which means the relationship between France and Paris. Oops, sorry. The relationship between France and Paris. I'm sorry, where is this movie? The relationship between France and Paris, the relationship between Italy and Rome, the relationship between Japan and Tokyo can all be encoded in the vector representation we have. And this method, which is called word-to-vec, is actually understanding words in some sense. They may not be understanding words directly, but they can, if you, so what this table shows you, for example, if you start with a relationship and say that here are the two words, France and Paris, give me similar pairs of other words. The system, the AI which is there, the NLP which is there, actually gives you examples like Italy and Rome, Japan and Tokyo. So, and if you say Einstein and scientist, it gives you examples like Messi and Mozart and violinist and so on, right? So there is some sense which the system has. It is not a very dumb system. This system sounds dumb, right? Because IntelliJ and JetBrains, it somehow seems that there is hardly any context which AI has, right? It's supposed to be that intelligent. But this 2013 paper by Mikhailov, he's a Google scientist. He showed that there is a way of having this kinds of information put into our AI systems. So if I take a more concrete example here, see here, Microsoft is Bobber, at that point it was, Google is Yahoo, I don't know what this means, IBM is McNeely, Apple is Jobs. So this information about company and CEO is encoded. And by that logic, we could encode information like IntelliJ and JetBrains, and that is indeed true. So if you actually train about to act on an open domain data set, you will get the relationship between IntelliJ and JetBrains reasonably well encoded. But so where is the problem? So this is where I say that algorithm is smart. So what we have done is we have moved all this smartness to the algorithm end, and by using these techniques, we are able to get some intelligence into the algorithm itself. So if we use an algorithm like word-to-vec, we would be able to infer the relationship between IntelliJ and JetBrains. But this leads to this leads to certain interesting problems, right? The first and foremost, it leads to a problem that the whole of this smartness bit that we are talking about is a property of the algorithm, and it resides outside the data. That creates some trouble. That creates trouble like the information gets lost if the development environment changes, or if something new happens, or you develop a new algorithm, you need to redo this whole thing again. So there are some problems of scale which are there. The second problem here, and in the smart algorithm world, Second problem is this is good for high resource domains. What I mean by high resource domains is to train this algorithm, you would see that this was trained on 783 million words. And 783 million words, finding 783 million words of training data to train this algorithm is difficult. This is possible only for certain types of, like you can go to Wikipedia, take all that information and then train your model. But not everything that we are looking for exists in Wikipedia, right? So there are new tools which don't have Wikipedia entries. There are new systems which are proprietary and don't have a name, and so on. So you can't have you can't have always intelligence in the algorithm to sort this out. So, but we can make data smarter, and this is the crux of the talk. And I hope that this gives enough background for people to understand what I'm going to talk about next. The way to do it, a way to solve some of these problems is to move this intelligence back into the data. And what do I mean by smart data? So smart data is connected. So think of data as boxes. These boxes are connected to other boxes, and their relationship has a property. So you say this is a box one, this is box two, and box one is a type of box two, or box one has some. I'll give some more concrete examples. So there is some sort of relationship between the boxes that and they're connected. So think of it like a tree or a graph which is connected. The second thing which gives data smartness is data is organized according to some principle. And what I mean by that is so again, if you go back to this intelligent thing, you just threw data into it, right? You never the fact that France is the capital of Paris is not here. France and Paris have a relationship, but what is that relationship? Nobody knows, right? Italy and Rome have the same relationship as France and Paris, but again, I don't know whether it's a capital or not. So this organization principle is the layer which gives some more meaning, some more smartness to the data. Given this, you can have multiple ways of storing data if you want to do it. RDBMS, a simple CSV Excel file. All of these are perfectly valid ways of storing smart data. But graphs are a much better approach for various fundamental reasons. I'm not going into that detail, but just take it from me that for now that graphs are one of the better ways of doing it. But people have used all kinds of other things to do it. The reason is graph databases are not the most well-developed databases at this point of time. There are only a few companies and a few graph databases which actually scale very well. But our traditional RDBMS, our SQL databases, they just do very well. Okay, so now we will go forward and we'll talk about how we are trying to solve these kinds of problems at Fresh Service, and how a knowledge graph kind of structure helps us. I'm not calling this a knowledge graph. I've used this word flexibly. Knowledge graph has a little more formal definition, there's a little more formal structure behind it, but this is as close to knowledge graph as possible. Right. So in this world, in the world of our graphs, this is an example. We have these nodes. So graphs have these properties called nodes. Nodes is nothing but a unit of data. It's like one row in your database, one row in your Excel sheet, right? And these nodes, you can have certain properties. So look at this graph. So I have encoded certain properties in this graph. I have said that this is a type called tool. And in this type tool has two things. It has a name, for example, PyCharm, and it has an org, which is called JetBrains. It has a name called VS Code, and it has a org called Microsoft. It has a tool called Illustrator. It has an org called Adobe, Photoshop, Adobe, and so on, right? So you have these nodes which are encoded. By itself, this is trivial. There is nothing great to it. But what we try and do next is interesting. Outside, so those were actual names of certain things. Outside of that, we try to define an organization principle of storing information in our world, in our knowledge graph. And that organization principle, there are multiple organization principles, but let me give you one, which is called a taxonomical representation. Here, what you do is you, outside of your world, you create a structure of how information should be organized according to your domain. So my domain is IT. In the IT domain, I encounter with things like development tools, office productivity, creativity tools, ERP, desktop security, and so on, right? So I have these whole main categories of things. There is no great hard and fast rule on what you want to call what. That depends on how you want to structure your domain. In the case of IT, it becomes relatively easy. So we have this. In this category, I can create subcategories. For example, in the development tools, I can have IDE, which is an integrated development environment, or I could have a software development kit called SDK. Similarly, if we take security, we could have antivirus as one type, and we can have VPN as another type. So this is what I decide is the organization principle. This is more like an art than an exact science, and depending on everybody's domain, everybody can create their own structure. Now let's merge what I showed you here with this, and this is not a very big deal. So what you see is this PyCharm. I'm sorry, this IntelliJ should have been a better example, but I created PyCharm. PyCharm is an IDE. VS Code is an IDE. Similarly, creativity tools, you have all these Adobe things under creativity tools. And you see these dotted arrows, right? These are the relationships which I spoke about. So tool is a type, PyCharm is a type of IDE. Adobe is a type of creativity tool. And Palo Alto Global Protect is a type of VPN, right? So we have that and we include that. Similarly, if you look at the arrows here, you say that SDK is a subclass or a subcategory of development tools, and antivirus is a subcategory of desktop software. So this top part of this is developed by me according to my own domain. There is no science here. It's only what I think is the correct thing. I'll come how we develop this bottom part at a little later stage. And I infer these connections. Using some trick. Now, what that trick is, all of those things I'll hopefully explain to you very quickly. Okay. Now, you need not have only one taxonomy for your data set. You could have multiple. So, for example, here we talked about types of tools according to how they are used. The usage is what is there on the right side. On the left side. On the right side, you could create a separate taxonomy which talks about the licenses of each of these tools. So you could have free and paid and freemium, and in free you could have open source and commercial license and so on, right? And each of these tools could also be tagged to this second taxonomy, which is around licensing. So you could have PyCharm is an open source tool which is free to use. PyCharm isn't, but I'm just saying that. Whereas Palo Alto Global Protect is a paid tool through and through. So using these kinds of taxonomies, you could have a sophisticated relationship between them. Again, remember that the taxonomy is manually created. I created it because I thought license is a relevant information to have in my knowledge graph, and I added it there. If we were able to a quick time check. I have 10 more minutes, right?
You can go on with your presentation, Saurav. That's not a time concern,
okay.
But yeah.
All right. So now let's say we have this I need access to JetBrains ID, which was our original question, right? What we typically do in these kinds of situations is we extract the entity. This is again a type of natural language processing technique, which is called entity extraction. So JetBrains is an entity of the type organization. Well, let's forget that, but it's a specific term, right? It's something which is interesting to us. So this is called an entity. We extract this JetBrains entity from the question that we have. And now if we search it, I'm sorry, that's why this example was poor. I have written PyCharm here, but think of this as IntelliJ. If I search for this in this kind of a graph, I will get as my first hit, right? I don't have any ID which is called JetBrains, but I have org which is called JetBrains, and I will get that hit. I'll know that this connection exists. And not only that, I'll also get hits from these other two things, right? I know that the first degree of separation exists between VS Code and PyCharm, right? So I know that these two are first degree cousins. So if an organization doesn't have any JetBrains or IntelliJ, but has VS Code, so VS Code is a known term in the organization, we can in our virtual agent, we can actually pull up VS Code and send it away as a substitute for JetBrains. So what I'm saying here is that if JetBrains doesn't exist in my database, there is no reason for me to say, oops, I can't do anything. I can give the next best alternate, provided I know what is the next best, provided I know that JetBrains is an IDE. And if I don't have JetBrains, any other IDE is the relevant or a good answer to that question, right? I mean, as a human being, if you go and ask your, you join an office and you say, hey, I used JetBrains in my previous organization, can I get access to JetBrains? Your colleague would say, dude, we don't use JetBrains. We use VS Code. Please use Visual Studio Code. And that is the kind of answer you would expect of a virtual agent as well. But to do that, you need to have all this information encoded. You can't just assume that JetBrains and VS Code would have some automated linkage, which this AI would just infer. It doesn't happen that way, right? So this solves our problem, right? So if we can develop a system like this, what we have on the right, then any questions like this, which are not present here in my database, I could still give a reasonably good answer to all of that. That is where the advantage of knowledge graph comes in. Now, okay, so this is a good idea to have this. Sounds like a good thing to do, but how do we build this? That's the tricky part, and that's a very, very complex task. So, and that involves a lot of machine learning, a lot of NLP to get this right. So it's not a hack. It's not that you just sit down one day and write down all these things and get it done. So what we do to do this is we build up a taxonomy for this domain, and this is something which I just said, right? I said that these things are basically my invention. I haven't I haven't done any analysis on why this should be the answer. I just know that this is a good way to represent my domain. So I build up a taxonomy on that. After I do that, I have to build a lot of these scraping and domain discovery tools. Why do I need that? So the point here is that how do I know JetBrains and IntelliJ are related? The only way to do this is go to their product website or a Wikipedia site, get that information, understand that JetBrains is the owner of PyCharm or IntelliJ, and that needs to be done. That needs to be properly created. I'll give you some examples of that. Then we have to build this NER tools, which is this thing, right? JetBrains to entity. So how do I map? How do I extract the entity out of the JetBrains? Then I have to develop information extraction systems. So information extraction system is, if I've given a text, how do I extract information that JetBrains is the owner of PyCharm, right? How do I do that? I have to also, okay, so information extraction, relationship extraction are kind of similar. The example which I just gave is a relationship extraction, that JetBrains is an owner of PyCharm, and that broadly falls under the category of information exchange. So if you look at this process, you scrape data, you identify domains, you extract that information, and you enrich your knowledge graph. So that's how you build a knowledge graph. It's way more complex than what it is here. Let me give you some examples. So this is work based on my colleagues Arnav and Gitanjali, who are working with me on this problem. So and to just make it a little more relevant to you, we extracted from Wikipedia. We just scraped Wikipedia and took out some information. And what you see here is PyCharm, and you have this text. This is the Wikipedia text, and you have the Wikipedia link, and you have certain categories which Wikimeta has, right? So you would get this text from somewhere like Wikipedia. That PyCharm is an integrated developer. You can already see that integrated development. And you see that IntelliJ idea is an integrated development environment. So you see this kind of information coming in from Wikipedia. It need not be Wikipedia. It could be any website. Wikipedia is typically for relatively well-known stuff. For many of the things that we deal with, they may not have Wikipedia articles, but you could probably scrape some other website which has that information. Then you do information extraction, that IE, which I talked about, to extract triples. So this is a triple from this information, right? From this text which we had, PyCharm is an integrated whatever. From that whole text, we extract information like PyCharm is something. PyCharm is a computer. So you would get this whole bunch of relationships from that one sort of text blob, right? Again, my colleagues Arnav and Gitanjali developed this thing. And you get this whole bunch of relationships which is available there. You immediately see that this is not the best thing that you can think of. This is not super clean. So you have to now invest in making it cleaner. In this whole context, this particular text is the only thing that you are interested in. The rest may not be correct. Python language is wrong, is a wrong statement to have, right? So if you can do all of this, like, and that is what we are doing right now, if you can scrape data, extract all that information, find out the relationship between this subject and this object, and encode this relationship in the graph, apply the taxonomy which I showed you, then you have a knowledge graph. So that's how it is. But as you see immediately that this is not trivial. Building this system is not trivial because there is a lot of noise which comes in. So how does this help us, right? So I gave you some examples of what knowledge graph means, and I also showed you a few slides on how to build one. They are not super detailed. They don't have all the nuts and bolts there, but it still hopefully serves the purpose. So, but how does this whole thing help us? The first point here is that that new tools keep coming to market. So as new tools keep coming to market, our knowledge graph is never complete. It's not that it is done and then we are done. So we have to keep this scraping and this searching for finding new information. A new tool has come up. A new ID has come up. The second problem is that every of our customers, right, every companies that that use our products, they have their own names of different things, right? So, for example, our data warehouse is called Baikal, right? It's our data lake is called Baikal from the Lake Baikal, which is in Siberia, Russia. Then people have all these interesting names for their conference room and Wi-Fi. So you have a conference room called Mordor, and how do you know that this is a different thing? So this kind of complexity, a graph allows us to encode all this information for every customer. So what we can do in things like this is, for a customer we can create for a customer we can create a new box and connect this box to this ID or to wherever, right? So even if we did not know that the customer has a ID called whatever, Noti, and we didn't know that, but once the customer tells us, or once we figure out a way to understand that it's an ID, we can just add a node and do it, and without changing anything else, everything else remains the same. So that's a great flexibility that we have. This also need not be complete. So if we don't know the relationship between two objects, we can keep that relationship open, and still the graph would make sense. So all of these are the reasons for using this kind of a graph structure to storing information. The second challenge is change. Companies acquire other companies change their offerings, for example, free to paid, and this again requires us to keep scraping this web, understand this new relationship as it emerges, and encode that relationship back into the knowledge graph. And if we are not good at that, then our knowledge graph will have junk data. So we have to put specific attention, time, thinking to ensure that these updates to the graphs are done in a systematic and a proper way. So we can encode partial information and we can detect conflict. So if for example, suddenly a tool changes from free to paid, we sense that there's a conflict because at this point, our knowledge graph says that this tool is free. However, our new information, which is coming in from scraping the web, says this is a paid tool now. Then you can actually have manually go and review. That's a very painful process of manually reviewing so much information, but that helps, and that is what keeps the knowledge graph sane. The third challenge is incompletion in some way. There's an interesting word, incompletion. So we can have, if we are using the structure that we followed, we can have a knowledge store which is not complete, which has holes, and that's great. That's fine with us because even with holes, we can make a lot of sense, and the holes gives us the opportunity to understand the changing dynamics of the outside world. The holes does not always mean that we made a mistake. The holes actually give us an indication that the world outside is changing. So that is why a new tool has come in and nobody knows who's making that tool, or a new tool has come in and gets acquired by somebody else, and suddenly the whole dynamics changes. So those kinds of things are taken care of by encoding knowledge in this kind of a knowledge graph. So this is the point which I was making, that it's a flexible method for us. It allows us to have incomplete information. It allows us to have conflicts. It allows us to add new taxonomy, and this is a great thing to have, right? So you could just tomorrow we think that other than this license thing, we also need information about the cost of the, like, how expensive is a tool, right? So we could create a new hierarchy which says extremely expensive, moderately expensive, or we could create a new tool which says, we could create a new hierarchy which says whether the tool is SaaS tool or an on-prem tool. We could have a new hierarchy which says whether that tool is compliant with GDPR and all kinds of security regulations or not. So all these taxonomical informations we can add later and keep connecting as we understand more. So today we don't know whether, for example, Adobe is a SaaS tool or not. I know it has some SaaS elements, but I don't know for sure. So we need not encode that information. We can encode that information only when we are aware of that information. And the way we will be aware of the information, as I said in my previous slides, we'll keep scraping the web, we'll keep extracting the information and the relationships from whatever we are scraping, and we will sort of keep building this tool iteratively for a long time. So this concludes my presentation on this topic. I still have about 9 minutes. I can take some questions, but I hope that till this point of time, it was useful introduction to the idea of knowledge graph.
Definitely, Saurabh. I think the session was great, and surely I think it has helped many users to know about the knowledge graphs and the applications that we have for it. So meanwhile, I think we can take some questions that we have in the Q&A poll. So if you mind taking up some questions from there, Saurabh.
Sure. So I'll just read out the question and maybe I'll just speak about it. I don't think I can type it right now.
Sure.
Given the complexity of how do you decide if this use case is to solve this quarter or the next? So how do we decide whether it has to be taken up this quarter or the next is if we have, so we have the way we work is we create priorities of what we want to do. Given the customer needs, given our roadmap, given the goals that we have set for ourselves, then we do an estimation of something like this. There will be a first order estimation that will be a very high level. So I would say that this requires me to invest 2 squads of effort for 6 months, 3 quarters or whatever. Then all of us will get to a consensus of when we should start this and how many squads should be involved, and then will it be can we create intermediate milestones and have something which we can deliver in this quarter, and what we should take back to the next quarter. So that's a little more nuanced. There are multiple steps involved in that. It's this kind of things this is too large of a thing to say that we'll just take it up right now.
So just
yeah, also there's a question on a chat which says, is it worth solving on? This is a tricky question. We typically do some POCs, etc., to figure out if we can quantify the impact improvement that we will get by doing something like this. Typically for improvement type things, like for example, this knowledge graph is supposed to improve our existing virtual agent. It's easier to quantify because you know how many cases you made a mistake. You can estimate how many cases a knowledge graph would help, and then you could take a call on that. But for new features, it is tricky. Is the solution you deploy the same for all customers or customized per customer, given that the challenges?
Sure. Would it be okay if we read out the question so the attendees?
Yeah, sure.
Yeah, Vineet, go ahead.
Yeah. So the question is the solution you deploy same for all customers or customized per customer? Given many challenges in training model and it's quite contextual, how do you transfer evolution of solution to other customers?
Yeah, so we typically have two types of mechanisms. One we call global models, which is same model applicable for multiple customers, and then we have some which are local models. At this point of time, we try and give as much flexibility to each customer, which means every customer gets their own model, or it gets their own way of customizing these things. So we build this for, we have the engineering in place to make this customization at scale for all of our customers based on the inputs they give us. So think of it as like the priority inbox for your Gmail, right? Every time you click, this is priority, this is not. Gmail in the backend learns from this feedback and improves, and we have something which is similar for this. Every time a customer gives some feedback to do this. How do we transfer evolution of solution, like new versions, etc., done to a specific customer? Now this is a little tricky thing, see, because if we learn something from a customer, if we use customers' data for certain things, we can't take this to another customer, because each customer's data is sacrosanct to them, right? So we can't. I can't learn from a customer, take their information, and then take it back and put it somewhere else. It's against regulations in almost all countries. So most of these times we understand the problems generically which each customer has. We have a mechanism of creating this feedback pipeline, and using this we try and improve the overall system. And whatever we do in terms of the overall system, if it doesn't conflict with one customer's specific thing, we roll it out to all our customers. And we again have the similar mechanism of letting our customers know what changes are coming, if that will conflict with their previous things, and if there is a mitigation strategy. So we give those kinds of options to the customer so that they are aware of what is going to hit them.
So we have the next question, Saurav, is how frequently do you train your NLP model to sync with the latest data?
There's no good answer to that. That depends on, we typically, there are two ways of doing it. The most typical mechanism that most of my teams use is based on a measure of how well the model is performing. So if we feel that the model is doing well, we don't change anything. If we feel that the model has degraded, then we take action. The action might include retraining or might include something else, but we don't have a set frequency of doing this.
Sure.
There are certain things which are customer triggered, where the customer expects something to happen. In which case, of course, we trigger a rerun.
Got it. Next question. I think there are a couple of questions bundled into one, but I'll just take the first question is, how do you ensure the knowledge graph is not error prone?
Oh, the knowledge graph will have errors. They'll have, like, I'm assuming you mean that the relationships or the issues are not correctly encoded. There will be problems. There is no way out of that. What we try and do is, when we enrich, so let's assume that you have a state on knowledge graph, which is great, right? Now, there are two reasons for things to change. One is something has changed in the external world. So you need to update your knowledge graph, right? Like, as I said, a company has been bought over by another company, or somebody has shut shop, and so on. Once that information comes in, we have to put in a mechanism of validating that information before we update the knowledge graph. So any updates to the knowledge graph goes through that mechanism. The existing knowledge graph also could have errors. And again, there is no great way of catching that. Our customers raise bugs. Our testing processes create these bugs, and we look at that and try and see if we made a mistake somewhere and so on. Sometimes, as I said, there are conflicts. So we learn a new relationship and we say that relationship is conflicting with our existing relationship. Then we again do a audit to see which one is the correct one. So there are a few things which we use to reduce error.
Sure. Okay, I'll just take one last question in the interest of time. How do you balance customization, localization with the feature available in global context, generalization as an add-on?
Can you repeat that question? Which question is there? Is this?
It's a question from Vijay. Can you see the second last question?
Yeah, I see that. How do you balance customization, localization with feature available in global context? I didn't understand this question. Can you ask Vijay to repeat this?
Okay. Yeah, I think.
Vijay, if you want to come forward and ask a question live, please raise your hand and I can unmute you. Meanwhile, Vineet will go with one more question.
Sure.
Okay, Vijay has raised his hand. I'm going to unmute him now. Go ahead, Vijay, ask your question.
Yeah, am I audible?
Yes.
Yeah, so my question is like, because you talked about the customer and having a customization. So how the balance has been attained by just giving a feature to a particular customer and again as a feature to overall product as such, because in order to make it as generalized for the product to be shipped completely for all the customers. So how do you balance this localization and generalization?
So I think Vijay, you probably got it a little. You didn't. I don't know which company you're working for, but for us, features are for all customers. That is, like I said, right? It is a SaaS product. There is no, we can't block or unblock features for customers. We can. I'm not saying we can't, but that is based on the tiers of the customer. So a premium, we have this enterprise, pro, and so on licenses. Depending on which license you have, you get the whole set of features. So you get all features. Let's say all our customers are enterprise customers. They will by default get all features and everything which is there. The customization is something which each of the customers would do for themselves. We don't do the customization. If one of our customers can buy our products as we give it to them, and then they can say that, you know, I want to create a specific example. I want to give a for me, Mordor doesn't mean a fictional place on in Lord of the Rings. For me, Mordor means Wi-Fi, right? Wi-Fi password or Wi-Fi SSID. That information that customer will encode in their version of Freshservice, and we will use that information to serve the employees better, right?
Cool. Thank you for answering that, Saurabh. Now, I think we've reached towards the end of our day today. And with that, I would just request you to, like, if you felt that, like, out of these questions, one of the questions, like one or two more questions which made sense or was very relevant to the topic today, if you could help us choose that, it will be helpful for us to give the recognition to the user, to the attendee today.
Yeah, I think one, we didn't cover all of that, but I thought Praveen's questions were very pertinent.
Okay.
Questions on error and then dynamic update of data and how the accuracy is measured and what kind of graph databases would I recommend. So I think that was a very packed question, but all relevant.
Perfect, great. Yes, so Praveen, congratulations on winning the Taylor Scholarship. And we'll get in touch with you with the award shortly.
Cool. Then, Shama, I think with that, over to you for the closing remarks.
Sure. Thank you, Saurabh, for the brilliant and engaging session. And thank you, audience, for the enthusiasm and participation. Due to time constraints, we could not take all the questions, but you always have the QR code or the link in the chat window to reach out to us and know more about the IPL School of Data Science and for career counseling. We have enjoyed having you with us, Saurabh. It's been a complete pleasure. Please accept this certificate of appreciation from the Institute, a small gesture. We are grateful for the time and effort you put to share your thoughts and the amazing insights drawn from your experience in the industry. So if you scan the QR code on the certificate, it will take you to a dedicated Hall of Fame page that we have created for you, which will hold the recording of this session. We'll share the recording on YouTube and you can share it with your network as well. Thank you once again for joining us.
Thank you for having me here.
And thank you, Vineet, for facilitating this session seamlessly. It was a pleasure having you here too.
Thank you. Yep. Thank you so much. Thank you. Thank you, Saurabh. Thanks, everyone.
Audience, if you found today's keynote useful, take a few seconds to share your feedback, experience, and perspectives on this session and inspire others to join the subsequent sessions. Please scan the QR codes to share your feedback. Your feedback is critical for us to make improvements for the next round of the festival.